4.2 Gameplay tags. Gameplay tags are hierarchical names in the form of parent, child, grandchild, that are registered with the Gameplay Tag Manager. These tags are incredibly useful for classifying and describing the state of an object. For example, if a character is stunned, we could give it a state, debuff, stun gameplay tag for the duration of the stun. You will find yourself replacing things that you used to handle with booleans or enums with gameplay tags and doing boolean logic on whether or not objects have certain gameplay tags. When giving tags to an object, we typically add them to its ASC if it has one so that GAS can interact with them. Ability System Component implements the iGameplay Tag Asset interface, giving functions to access its own gameplay tags. Multiple gameplay tags can be stored in an fGameplay tag container. It is preferable to use a gameplay tag container over a tare fGameplay tag, since the gameplay tag containers add some efficiency magic. While tags are standard F names, they can be efficiently packed together in fGameplay tag containers for replication if fast replication is enabled in the project settings. Fast replication requires that the server and the clients have the same list of gameplay tags. This generally shouldn't be a problem, so you should enable this option. Gameplay tag containers can also return a tare fGameplay tag for iteration. Gameplay tags stored in fGameplay tag count container have a tag map that stores the number of instances of that gameplay tag. A fGameplay tag count container may still have the gameplay tag in it, but its tag map count is 0. You may encounter this while debugging if an ASC still has a gameplay tag. Any of the has tag, or has matching tag, or similar functions will check the tag map count and return false if the gameplay tag is not present or its tag map count is 0. Gameplay tags must be defined ahead of time in the default gameplay tags.ini. The Unreal Engine editor provides an interface in the project settings to let developers manage gameplay tags without needing to manually edit the default gameplay tags.ini. The gameplay tag editor can create, rename, search for references, and delete gameplay tags. Gameplay tag editor in project settings. Searching for gameplay tag references will bring up the familiar reference viewer graph in the editor showing all the assets that reference the gameplay tag. This will not, however, show any C++ classes that reference the gameplay tag. Renaming gameplay tags creates a redirect so that assets still referencing the original gameplay tag can redirect to the new gameplay tag. I prefer if possible to instead create a new gameplay tag, update all the references manually to the new gameplay tag, and then delete the old gameplay tag to avoid creating a redirect. In addition to fast replication, the gameplay tag editor has an option to fill in commonly replicated gameplay tags to optimize them further. Gameplay tags are replicated if they're added from a gameplay effect. The ASC allows you to add loose gameplay tags that are not replicated and must be managed manually. The sample project uses a loose gameplay tag for state, dead, so that the owning clients can immediately respond to when their health drops to 0. Respawning manually sets the tag map count back to 0. Only manually adjust the tag map count when working with loose gameplay tags. It is preferable to use the Ability System Component, add loose gameplay tag, and Ability System Component, remove loose gameplay tag, functions than manually adjusting the tag map count. Getting a reference to a gameplay tag in C++, fGameplay tag, request gameplay tag, fname, your.gameplay tag.name, for advanced gameplay tag manipulation like getting the parent or children gameplay tags, look at the functions offered by the Gameplay Tag Manager. To access the Gameplay Tag Manager, include gameplay tag manager.h and call it with uGameplay Tag Manager, get.function name. The Gameplay Tag Manager actually stores the gameplay tags as relational nodes, parent, child, etc., for faster processing than constant string manipulation and comparisons. Gameplay tags and gameplay tag containers can have the optional property specifier meta equals, categories equals, gameplay queue, that filters the tags in the blueprint to show only gameplay tags that have the parent tag of gameplay queue. This is useful when you know the gameplay tag or gameplay tag container variable should only be used for gameplay queues. Alternatively, there's a separate structure called fGameplayQueue tag that encapsulates a fGameplay tag and also automatically filters gameplay tags in Blueprint to only show those tags with the parent tag of GameplayQueue. If you want to filter a gameplay tag parameter in a function, use the function specifier meta equals, gameplay tag filter equals, GameplayQueue. Gameplay tag container parameters in functions cannot be filtered. If you would like to edit your engine to allow this, look at how sGameplay tag graph pin, parse default value data, from engine /plugins /editor /gameplay tags editor /source /gameplay tags editor /private /sgameplay tag graph pin.cpp calls filter string equals uGameplay tags manager get categories meta from field, pin struct type, and passes filter string to sGameplay tag widget in sGameplay tag graph pin, get list content. The gameplay tag container version of these functions in engine /plugins /editor /gameplay tags editor /source /gameplay tags editor /private /sgameplay tag container graph pin.cpp do not check for the meta field properties and pass along the filter. The sample project extensively uses gameplay tags. Up arrow back to top 4.2.1 responding to changes in gameplay tags. The ASC provides a delegate for when gameplay tags are added or removed. It takes an gameplay tag event type that can specify only to fire when the gameplay tag is added / removed or for any change in the gameplay tag's tag map count. Ability System Component - register gameplay tag event, fGameplay tag, request gameplay tag, fname, state. Debuff, stun, gameplay tag event type, new or removed, add uObject, this, and agd player state, stun tag changed. The callback function has a parameter for the gameplay tag and the new tag count. Virtual void stun tag changed, const f gameplay tag callback tag, int 32 new count, up arrow back to top 4.2.2 loading gameplay tags from plugin.ini files. If you create a plugin with its own .ini files with gameplay tags, you can load that plugin's gameplay tag.ini directory in your plugin startup module function. For example, this is how the Common Conversation plugin that comes with Unreal Engine does it. The startup module function initializes the Common Conversation runtime module. It retrieves the Common Conversation plugin using iPlugin Manager and ensures it's valid. Then, it adds the plugin's config/tags folder to the Gameplay Tags Manager's search paths, allowing the engine to find and load tag definitions for the module. This would look for the directory plugins /common conversation /config /tags and load any .ini files with gameplay tags in them into your project, and the engine starts up if the plugin is enabled. Up arrow back to top 4.3 attributes. 4.3.1 attribute definition. Attributes are float values defined by the struct fGameplay attribute data. These can represent anything from the amount of health a character has to the character's level to the number of charges that a potion has. If it is a gameplay-related numerical value belonging to an actor, you should consider using an attribute for it. Attributes should generally only be modified by gameplay effects so that the ASC can predict the changes. Attributes are defined by and live in an attribute set. The attribute set is responsible for replicating attributes that are marked for replication. See the section on attribute sets for how to define attributes. Tip: if you don't want an attribute to show up in the editor's list of attributes, you can use the meta equals, hide in details view, property specifier. Up arrow back to top 4.3. To base value versus current value. An attribute is composed of two values, a base value and a current value. The base value is the permanent value of the attribute, whereas the current value is the base value plus temporary modifications from gameplay effects. For example, your character may have a move speed attribute with a base value of 600 units/second. Since there are no gameplay effects modifying the move speed yet, the current value is also 600 U/s. 3 meta attributes. Some attributes are treated as placeholders for temporary values that are intended to interact with attributes. These are called meta attributes. For example, we commonly define damage as a meta attribute. Instead of a gameplay effect directly changing our health attribute, we use a meta attribute called damage as a placeholder. This way the damage value can be modified with buffs and debuffs in a gameplay effect execution calculation and can be further manipulated in the attribute set, for example subtracting the damage from a current shield attribute, before finally subtracting the remainder from the health attribute. The damage meta attribute has no persistence between gameplay effects and is overridden by every one. Meta attributes are not typically replicated. Meta attributes provide a good logical separation for things like damage and healing between how much damage did we do, and what do we do with this damage. This logical separation means our gameplay effects and execution calculations don't need to know how the target handles the damage. Continuing our damage example, the gameplay effect determines how much damage and then the attribute set decides what to do with that damage. Not all characters may have the same attributes, especially if you use subclassed attribute sets. The base attribute set class may only have a health attribute, but a subclassed attribute set may add a shield attribute. The subclassed attribute set with the shield attribute would distribute the damage received differently than the base attribute set class. While meta attributes are a good design pattern, they are not mandatory. If you only ever have one execution calculation used for all instances of damage and one attribute set class shared by all characters, then you may be fine doing the damage distribution to health, shields, etc. inside of the execution calculation and directly modifying those attributes. You'll only be sacrificing flexibility, but that may be okay for you. Up arrow back to top 4.3.4. Responding to attribute changes. To listen for when an attribute changes to update the UI or other gameplay, use uAbility system component, get gameplay attribute value change delegate, fGameplay attribute. This function returns a delegate that you can bind to that will be automatically called whenever an attribute changes. The delegate provides a fOnAttribute change data parameter with the new value, old value, and fGameplay effect mod callback data. Note, the fGameplay effect mod callback data will only be set on the server. Ability system component dash get gameplay attribute value change delegate, attribute set base dash get health attribute, dot add uObject, this, and AGD player state, health changed, virtual void health changed, const fOnAttribute change data and data. The sample project binds to the attribute value changed delegates on the GD player state to update the HUD and to respond to player death when health reaches 0. A custom blueprint node that wraps this into an async task is included in the sample project. It is used in the UI_HUD UMG widget to update the health, mana, and stamina values. This async task will live forever until manually called end task, which we do in the UMG widget's destruct event. See async task attribute changed.h/cpp. Listen for attribute change BP node. Up arrow back to top 4.3.5. Derived attributes. To make an attribute that has some or all of its value derived from one or more other attributes, use an infinite gameplay effect with one or more attribute-based or MMC modifiers. The derived attribute will update automatically when an attribute that it depends on is updated. The final formula for all the modifiers on a derived attribute is the same formula for modifier aggregators. If you need calculations to happen in a certain order, do it all inside of an MMC. Current value plus additive, * multiplicative, /division note. If playing with multiple clients in PIE, you need to disable run under one process in the editor preferences, otherwise the derived attributes will not update when their independent attributes update on clients other than the first. In this example, we have an infinite gameplay effect that derives the value of test_A from the attributes test_B and test_C in the formula test_A equals test_A plus test_B asterisk 2 asterisk test_C. Test_A recalculates its value automatically whenever any of the attributes update their values. Derived attribute example up arrow back to top 4.4 attribute set 4.4.1 attribute set definition. The attribute set defines, holds, and manages changes to attributes. Developers should subclass from attribute set. Creating an attribute set in an owner actors constructor automatically registers it with its ASC. This must be done in C++. Up arrow back to top 4.4.2 attribute set design. An ASC may have one or many attribute sets. Attribute sets have negligible memory overhead, so how many attribute sets to use is an organizational decision left up to the developer. It is acceptable to have one large monolithic attribute set shared by every actor in your game and only use attributes if needed while ignoring unused attributes. Alternatively, you may choose to have more than one attribute set representing groupings of attributes that you selectively add to your actors as needed. For example, you could have an attribute set for health-related attributes, an attribute set for mana-related attributes, and so on. In a MOBA game, heroes might need mana but minions might not. Therefore the heroes would get the mana attribute set and minions would not. Additionally, attribute sets can be subclassed as another means of selectively choosing which attributes an actor has. Attributes are internally referred to as attribute set class name. Attribute name. When you subclass an attribute set, all of the attributes from the parent class will still have the parent class's name as the prefix. While you can have more than one attribute set, you should not have more than one attribute set of the same class on an ASC. If you have more than one attribute set from the same class, it won't know which attribute set to use and will just pick one. For .4.2.1 subcomponents with individual attributes. In the scenario where you have multiple damageable components on a pawn like individually damageable armor pieces, I recommend that if you know the maximum number of damageable components that a pawn could have to make that many health attributes on one attribute set, damageable comp health 0, damageable comp health 1, etc. to represent logical slots for those damageable components. In your damageable component class instance, assign the slot number attribute that can be read by gameplay abilities or executions to know which attribute to apply damage to. Pawns that have less than the maximum number or 0 of damageable components are fine. Just because an attribute set has an attribute, doesn't mean that you have to use it. Unused attributes take up trivial amount of memory. If your subcomponents need many attributes each, there's potentially an unbounded number of subcomponents. The subcomponents can detach and be used by other players, e.g. weapons, or for any other reason this approach doesn't work for you, I'd recommend switching away from attributes and instead store plain old floats on the components. See item attributes. For .4.2.2 adding removing attribute sets at runtime. Attribute sets can be added and removed from an ASC at runtime. However, removing attribute sets can be dangerous. For example, if an attribute set is removed on a client before the server and an attribute value change is replicated to client, the attribute won't find its attribute set and crash the game. On weapon, add to inventory, ability system component dash. Get spawned attributes underscore mutable, add unique, weapon attribute set pointer, ability system component dash force replication, on weapon remove from inventory, ability system component dash get spawned attributes underscore mutable, remove, weapon attribute set pointer, ability system component dash force replication, 4.4.2.3 item attributes, weapon ammo. There's a few ways to implement equipable items with attributes, weapon ammo, armor durability, etc. All of these approaches store values directly on the item. This is necessary for items that can be equipped by more than one player over its lifetime. Use plain floats on the item, recommended, separate attribute set on the item, separate ASC on the item. 4.4.2.3.1 plain floats on the item instead of attributes, store plain float values on the item class instance. Fortnite and GS Shooter handle gun ammo this way. For a gun, store the max clip size, current ammo in clip, reserve ammo, etc. directly as replicated floats, con_owner only, on the gun instance. If weapons share reserve ammo, you would move the reserve ammo onto the character as an attribute in a shared ammo attribute set. Reload abilities can use a cost GE to pull from reserve ammo into the gun's float clip ammo. Since you're not using attributes for current clip ammo, you will need to override some functions in gameplay ability to check and apply cost against the floats on the gun. Making the gun the source object in the gameplay ability spec when granting the ability means you'll have access to the gun that granted the ability inside the ability. To prevent the gun from replicating back the ammo amount and clobbering the local ammo amount during automatic fire, disable replication while the player has a is firing gameplay tag in pre-replication. You're essentially doing your own local prediction here. The pre-replication function in the AGS weapon class customizes which properties are replicated based on specific conditions before replication occurs. Call to super, pre-replication. Ensures the base class logic for pre-replication is executed first. Dorp lifetime _active override, overrides the replication condition for primary clip ammo and secondary clip ammo. These properties will only replicate if ability system component is valid, ability system component, and the ability system component does not have the weapon is firing tag gameplay tag. Summary, this function dynamically controls replication of primary clip ammo and secondary clip ammo to reduce unnecessary network updates when the weapon is firing. Benefits, avoids limitations of using attribute sets, see below, limitations, cannot use existing gameplay effect workflow, cost GEs for ammo use, etc. Requires work to override key functions on gameplay ability to check and apply ammo costs against the gun's floats 4.4.2.3.2 attribute set on the item using a separate attribute set on the item that gets added to the player's ASC on adding it to the player's inventory can work, but it has some major limitations. I had this working in early versions of GAS Shooter for the weapon ammo. The weapon stores its attributes such as max clip size, current ammo in clip, reserve ammo, etc. in an attribute set that lives on the weapon class. If weapons share reserve ammo, you would move the reserve ammo onto the character in a shared ammo attribute set. When a weapon is added to the player's inventory on the server, the weapon would add its attribute set to the player's ASC spawned attributes. The server would then replicate this down to the client. If the weapon is removed from the inventory, it would remove its attribute set from the ASC spawned attributes. When the attribute set lives on something other than the owner actor, say a weapon, you'll initially get some compilation errors in the attribute set. The fix is to construct the attribute set in begin play, instead of in the constructor, and to implement ability system interface, set the pointer to the ASC when you add the weapon to the player inventory, on the weapon. In the begin play function of AGS weapon. Check if attribute set is null. If attribute set is not already initialized, it creates a new instance of UGS weapon attribute set using new object. Assign ownership. This pointer is passed as the owner of the UGS weapon attribute set, ensuring the new object is properly tied to the weapon instance. Summary, this ensures that attribute set is initialized at the start of play, creating it dynamically if it hasn't already been set. You can see it in practice by checking out this older version of GAS Shooter. Benefits, can use existing gameplay ability in gameplay effect workflow, cost GEs for ammo use, etc., simple to set up for a very small set of items limitations, you have to make a new attribute set class for every weapon type. ASCs can only functionally have one attribute set instance of a class since changes to an attribute look for the first instance of their attribute set class in the ASC spawned attributes array. Additional instances of the same attribute set class are ignored. You can only have one of each type of weapon in the player's inventory due to previous reason of one attribute set instance per attribute set class. Removing an attribute set is dangerous. In GAS Shooter, if the player killed himself from a rocket, the player would immediately remove the rocket launcher from his inventory, including its attribute set from the ASC. When the server replicated that the rocket launcher's ammo attribute changed, the attribute set no longer existed on the client's ASC and the game crashed. 4.4.2.3.3 ASC on the item. Putting a whole ability system component on each item is an extreme approach. I have not personally done this, nor have I seen it in the wild. It would take a lot of engineering to make it work. Is it viable to have several ability system components which have the same owner but different avatars, e.g. on pawn and weapon/items/projectiles with owner set to player state? The first problem I see there would be implementing the gameplay tag asset interface and ability system interface on the owning actor. The former may be possible, just aggregate the tags from all ASCs, but watch out, as all matching gameplay tags may be met only via cross ASC aggregation. It wouldn't be enough to just forward that calls to each ASC and or the results together. But the later is even trickier, which ASC is the authoritative one? If someone wants to apply a GE, which one should receive it? Maybe you can work these out, but this side of the problem will be the hardest. Owners will have multiple ASCs beneath them. Separate ASCs on the pawn and the weapon can make sense on its own though. E.G, distinguishing between tags that describe the weapon versus those that describe the owning pawn. Maybe it does make sense that tags granted to the weapon also apply to the owner and nothing else. E.G, attributes and GEs are independent, but the owner will aggregate the owned tags like I describe above. This could work out, I am sure. But having multiple ASCs with the same owner may get dicey. Dave Ratty from Epic's answer to community questions number 6 benefits, can use existing gameplay ability in gameplay effect workflow, cost GEs for ammo use, etc., can reuse attribute set classes, one on each weapon's ASC, limitations, unknown engineering cost. Is it even possible? Up arrow back to top 4.4.3 defining attributes. Attributes can only be defined in C++ in the attribute sets header file. It is recommended to add this block of macros to the top of every attribute set header file. It will automatically generate getter and setter functions for your attributes. This code defines a replicated health attribute in a UGD attribute set base class using Unreal Engine's gameplay ability system, GAS. Key components, attribute_accessors macro, expands into getter, setter, and initializer functions for the health attribute. This simplifies access to the health variable. Health attribute definition, F gameplay attribute data health stores the health value. A property, replicated using equals onRep_health, ensures it replicates and triggers onRep_health when updated. OnRep_health function, called when health is replicated. Uses JMEPLAYATTRIBUT_rep notify to handle prediction and rollback. Replication setup in get lifetime replicated props, dorp lifetime_condition_notify ensures health always replicates, con_none, and triggers onRep_health. Summary, this setup ensures that health is properly replicated, predicted, and notified across the network, enabling smooth synchronization in multiplayer gameplay. Rep notify_always tells the onRep function to trigger if the local value is already equal to the value being repped down from the server, due to prediction. By default it won't trigger the onRep function if the local value is the same as the value being repped down from the server. If the attribute is not replicated like a meta attribute, then the onRep and get lifetime replicated prop steps can be skipped. Up arrow back to top 4.4.4 initializing attributes. There are multiple ways to initialize attributes, set their base value and consequently their current value to some initial value. Epic recommends using an instant gameplay effect. This is the method used in the sample project too. See GE_hero attributes blueprint in the sample project for how to make an instant gameplay effect to initialize attributes. Application of this gameplay effect happens in C++. If you use the attribute_accessors macro when you define your attributes, an initialization function will automatically be generated on the attribute set for each attribute that you can call at your leisure in C++. //init health, float initial value, is an automatically generated function for an attribute, health, defined with the attribute_accessors macro attribute set -init health, 100.0f, see attributeset.h for more ways to initialize attributes. Note, prior to 4.24, f attribute set init discrete levels did not work with f gameplay attribute data. It was created when attributes were raw floats and will complain about f gameplay attribute data not being plain old data, pod. This is fixed in 4.24 https://issues.unrealengine.com/issue/ue-76557. Up arrow back to top 4.4.5 pre-attribute change, const f gameplay attribute and attribute, float and new value, is one of the main functions in the attribute set to respond to changes to an attribute's current value before the change happens. It is the ideal place to clamp incoming changes to current value via the reference parameter new value. For example, to clamp move speed modifiers, the sample project does it like so: if attribute = get move speed attribute // cannot slow less than 150 units /s and cannot boost more than 1000 units /s new value equals fmath, clamp if float, new value, 150, 1000, the get move speed attribute function is created by the macro block that we added to the attributeset.h, defining attributes. This is triggered from any changes to attributes, whether using attribute setters, defined by the macro block in attributeset.h, defining attributes, or using gameplay effects. Note, any clamping that happens here does not permanently change the modifier on the ASC. It only changes the value returned from querying the modifier. This means anything that recalculates the current value from all of the modifiers like gameplay effect execution calculations and modifier magnitude calculations need to implement clamping again. Note, Epic's comments for pre-attribute change say not to use it for gameplay events and instead use it mainly for clamping. The recommended place for gameplay events on attribute change is uAbility system component, get gameplay attribute value change delegate, f gameplay attribute responding to attribute changes. Up arrow back to top 4.4.6 post gameplay effect execute, const f gameplay effect mod callback data and data. Only triggers after changes to the base value of an attribute from an instant gameplay effect. This is a valid place to do more attribute manipulation when they change from a gameplay effect. For example, in the sample project we subtract the final damage meta attribute from the health attribute here. If there was a shield attribute, we would subtract the damage from it first before subtracting the remainder from health. The sample project also uses this location to apply hit react animations, show floating damage numbers, and assign experience and gold bounties to the killer. By design, the damage meta attribute will always come through an instant gameplay effect and never the attribute setter. Other attributes that will only have their base value changed from instant gameplay effects like mana and stamina can also be clamped to their maximum value counterpart attributes here. Note, when post gameplay effect execute is called, changes to the attribute have already happened, but they have not replicated back to clients yet, so clamping values here will not cause two network updates to clients. Clients will only receive the update after clamping. Up arrow back to top 4.4.7 on attribute aggregator created, const f gameplay attribute and attribute, f aggregator * new aggregator, triggers when an aggregator is created for an attribute in this set. It allows custom setup of f aggregator evaluate metadata. Aggregator evaluate metadata is used by the aggregator in evaluating the current value of an attribute based on all the modifiers applied to it. By default, aggregator evaluate metadata is only used by the aggregator to determine which modifiers qualify with the example of most negative mod _ all positive mods, which allows all positive modifiers but restricts negative modifiers to only the most negative one. This was used by Paragon to only allow the most negative move speed slow effect to apply to a player regardless of how many slow effects were on them at any one time while applying all positive move speed buffs. Modifiers that don't qualify still exist on the ASC, they just aren't aggregated into the final current value. They can potentially qualify later once conditions change, like in the case if the most negative modifier expires, the next most negative modifier, if one exists, then qualifies. To use aggregator evaluate metadata in the example of only allowing the most negative modifier and all positive modifiers, virtual void on attribute aggregator created, const f gameplay attribute and attribute, f aggregator * new aggregator, const override, void ugs attribute setbase, on attribute aggregator created, const f gameplay attribute and attribute, f aggregator * new aggregator, const super, on attribute aggregator created, attribute, new aggregator, if, new aggregator, return, if, attribute equals. Get move speed attribute, new aggregator - evaluation metadata equals and f aggregator evaluate metadata library, most negative mod _ all positive mods, your custom aggregator evaluate metadata for qualifiers should be added to f aggregator evaluate metadata library as static variables. Up arrow back to top 4.5 Gameplay Effects 4.5.1 Gameplay Effect Definition Gameplay Effects, GE, are the vessels through which abilities change attributes and gameplay tags on themselves and others. They can cause immediate attribute changes like damage or healing or apply long-term status buffs/debuffs like a move speed boost or stunning. The Gameplay Effect class is meant to be a data-only class that defines a single gameplay effect. No additional logic should be added to gameplay effects. Typically, designers will create many blueprint child classes of Gameplay Effect. Gameplay effects change attributes through modifiers and executions. Gameplay effect execution calculation. Gameplay effects have three types of duration: instant, duration, and infinite. Additionally, gameplay effects can add/execute gameplay cues. An instant gameplay effect will call execute on the gameplay cue gameplay tags, whereas a duration or infinite gameplay effect will call add and remove on the gameplay cue gameplay tags. Duration type gameplay cue event when to use instant execute for immediate permanent changes to attributes base value. Gameplay tags will not be applied, not even for a frame. Duration add and remove for temporary changes to attributes current value and to apply gameplay tags that will be removed when the gameplay effect expires or is manually removed. The duration is specified in the Gameplay Effect class/blueprint. Infinite add and remove for temporary changes to attributes current value and to apply gameplay tags that will be removed when the gameplay effect is removed. These will never expire on their own and must be manually removed by an ability or the ASC. Duration and infinite gameplay effects have the option of applying periodic effects that apply its modifiers and executions every X seconds as defined by its period. Periodic effects are treated as instant gameplay effects when it comes to changing the attribute's base value and executing gameplay cues. These are useful for damage over time, DOT type effects. Note, periodic effects cannot be predicted. Duration and infinite gameplay effects can be temporarily turned off and on after application if their ongoing tag requirements are not met/met, gameplay effect tags. Turning off a gameplay effect removes the effects of its modifiers and applied gameplay tags but does not remove the gameplay effect. Turning the gameplay effect back on reapplies its modifiers and gameplay tags. If you need to manually recalculate the modifiers of a duration or infinite gameplay effect, say you have an MMC that uses data that doesn't come from attributes, you can call Ability System Component Active Gameplay Effects. Set Active Gameplay Effect Level, Active Gameplay Effect Handle Active Handle, in 32 new level, with the same level that it already has using Ability System Component Active Gameplay Effects. Get Active Gameplay Effect, Active Handle, Spec.get Level. Modifiers that are based on backing attributes automatically update when those backing attributes update. The key functions of Set Active Gameplay Effect Level, to update the modifiers are, mark item dirty, effect, spec.calculate modifier magnitudes, // private function. Otherwise we'd call these three functions without needing to set the level to what it already is. Update all aggregator mod magnitudes, effect. Gameplay effects are not typically instantiated. When an ability or ASC wants to apply a gameplay effect, it creates a gameplay effect spec from the gameplay effects class default object. Successfully applied gameplay effect specs are then added to a new struct called Active Gameplay Effect, which is what the ASC keeps track of in a special container struct called Active Gameplay Effects. Up arrow back to top 4.5.2 Applying gameplay effects. Gameplay effects can be applied in many ways, from functions on gameplay abilities and functions on the ASC, and usually take the form of apply gameplay effect to. The different functions are essentially convenience functions that will eventually call Ability System Component apply gameplay effect spec to self on the target. To apply gameplay effects outside of a gameplay ability, for example from a projectile, you need to get the target's ASC and use one of its functions to apply gameplay effect to self. You can listen for when any duration or infinite gameplay effects are applied to an ASC by binding to its delegate, Ability System Component -on active gameplay effect added delegate to self. Add object, this, and APA character base on active gameplay effect added callback, the callback function. Virtual void on active gameplay effect added callback, Ability System Component * target, const f gameplay effect spec and spec applied, f active gameplay effect handle active handle. The server will always call this function regardless of replication mode. The autonomous proxy will only call this for replicated gameplay effects in full and mixed replication modes. Simulated proxies will only call this in full replication mode. Up arrow back to top 4.5.3 Removing gameplay effects. Gameplay effects can be removed in many ways, from functions on gameplay abilities and functions on the ASC, and usually take the form of remove active gameplay effect. The different functions are essentially convenience functions that will eventually call Active Gameplay Effects container, remove active effects, on the target. To remove gameplay effects outside of a gameplay ability, you need to get the target's ASC and use one of its functions to remove active gameplay effect. You can listen for when any duration or infinite gameplay effects are removed from an ASC by binding to its delegate, Ability System Component -on any gameplay effect remove delegate. Add object, this, and APA character base on remove gameplay effect callback, the callback function, virtual void on remove gameplay effect callback, const f active gameplay effect and effect removed. The server will always call this function regardless of replication mode. The autonomous proxy will only call this for replicated gameplay effects in full and mixed replication modes. Simulated proxies will only call this in full replication mode. Up arrow back to top 4.5.4 Gameplay effect modifiers. Modifiers change an attribute and are the only way to predictively change an attribute. A gameplay effect can have 0 or many modifiers. Each modifier is responsible for changing only one attribute via a specified operation. Operation description adds the result to the modifier's specified attribute. Use a negative value for subtraction. Multiply multiplies the result to the modifier's specified attribute. Divide divides the result against the modifier's specified attribute. Overrides the modifier's specified attribute with the result. The current value of an attribute is the aggregate result of all of its modifiers added to its base value. The formula for how modifiers are aggregated is defined as follows in faggregator mod channel, evaluate with base in gameplay effect aggregator.cpp, inline base value plus additive, asterisk multiplicative, / division. Any override modifiers will override the final value with the last applied modifier taking precedence. Note, for percentage-based changes, make sure to use the multiply operation so that it happens after addition. Note, prediction has trouble with percentage changes. There are 4 types of modifiers: scalable float, attribute-based, custom calculation class, and set by caller. They all generate some float value that is then used to change the specified attribute of the modifier based on its operation. Modifier type description. Scalable float. Scalable floats are a structure that can point to a data table that has the variables as rows and levels as columns. The scalable floats will automatically read the value of the specified table row at the ability's current level, or different level if overridden on the gameplay effect spec. This value can further be manipulated by a coefficient. If no data table/row is specified, it treats the value as a 1, so the coefficient can be used to hard code in a single value at all levels. Scalable float. Attribute-based modifiers take the current value or base value of a backing attribute on the source, who created the gameplay effect spec, or target, who received the gameplay effect spec, and further modifies it with a coefficient and pre- and post-coefficient additions. Snapshotting means the backing attribute is captured and the gameplay effect spec is created, whereas no snapshotting means the attribute is captured when the gameplay effect spec is applied. Custom calculation class. Custom calculation class provides the most flexibility for complex modifiers. This modifier takes a modifier magnitude calculation class and can further manipulate the resulting float value with a coefficient and pre- and post-coefficient additions. Set by caller. Set by caller modifiers are values that are set outside of the gameplay effect at runtime by the ability or whoever made the gameplay effect spec on the gameplay effect spec. For example, you would use a set by caller if you want to set the damage to be based on how long the player held down a button to charge the ability. Set by callers are essentially tmap gameplay tag, float that live on the gameplay effect spec. The modifier is just telling the aggregator to look for a set by caller value associated with the supplied gameplay tag. The set by callers used by modifiers can only use the gameplay tag version of the concept. The fname version is disabled here. If the modifier is set to set by caller but a set by caller with the correct gameplay tag does not exist on the gameplay effect spec, the game will throw a runtime error and return a value of 0. This might cause issues in the case of a divide operation. See set by callers for more information on how to use set by callers. Up arrow back to top 4.5.4.1. Multiply and divide modifiers. By default, all multiply and divide modifiers are added together before multiplying or dividing them into the attribute's base value. This code calculates the final value of a gameplay ability system, GAS, aggregator modifier by applying different types of gameplay effect modifications. Key components. 1. Evaluate with base function takes an inline base value and modifies it using additive, multiplicative, and division effects. Calls some mods for each type of gameplay modifier, additive, multiplicative, division. Uses gameplay effect utilities, get modifier bias by modifier op to adjust bias values. The final value is computed as, inline base value plus additive, asterisk operator multiplicative, / division, inline base value plus additive, asterisk operator multiplicative. / division ensuring that additive mods apply first, multiplicative mods scale the result, and division mods normalize the value. 2. Some mods function iterates through an array of aggregator mod modifiers. Starts with a bias value and adjusts it based on mod.evaluated magnitude. Only considers mods that pass mod qualifies. Summary. This ensures that all gameplay effect modifications are applied correctly to an attribute by first adding, then multiplying, and finally dividing, making it a core part of GAS attribute modification calculations. From gameplay effect aggregator.cpp, both multiply and divide modifiers have a bias value of 1 in this formula, addition has a bias of 0. So it would look something like 1 plus mod 1.magnitude 1 plus mod 2.magnitude 1 plus. This formula leads to some unexpected results. Firstly, this formula adds all the modifiers together before multiplying or dividing them into the base value. Most people would expect it to multiply or divide them together. For example, if you have two multiply modifiers of 1.5, most people would expect the base value to be multiplied by 1.5 times 1.5 is equal to 2.25. Instead, this adds the 1.5s together to multiply the base value by 2, 50% increase plus another 50% increase equals 100% increase. This was for the example from gameplay prediction.h of a 10% speed buff on 500 base speed would be 550. Add another 10% speed buff and it will be 600. Secondly, this formula has some undocumented rules about what values can be used as it was designed with Paragon in mind. Rules for multiply and divide multiplication addition formula, no more than one value 1, and any number of values, 1, 2, or 1 value equals 2, the bias in the formula basically subtracts out the integer digit of numbers in the range, 1, 2. The first modifier's bias subtracts out from the starting sum value, set to the bias before the loop, which is why any value by itself works and why one value 1 will work with the numbers in the range, 1, 2. Some examples with multiply, multipliers, 0.51 plus, 0.5 to 1, equals 0.5, correct multipliers, 0.5, 0.51 plus, 0.5 to 1, plus, 0.5 to 1, equals 0, incorrect expected 1. Multiple values less than 1 don't make sense for adding multipliers. Paragon was designed to only use the greatest negative value for multiply modifiers, so there would only ever be at most one value less than 1 multiplying into the base value. Multipliers, 1.1, 0.51 plus, 0.5 to 1, plus, 1.1 to 1, equals 0.6, correct multipliers, 5, 5 1 plus, 5 to 1, plus, 5 to 1, equals 9, incorrect expected 10. Will always be the sum of the modifiers, number of modifiers plus 1. Many games will want their multiply and divide modifiers to multiply and divide together before applying to the base value. To achieve this, you will need to change the engine code for faggregator mod channel, evaluate with base. Float faggregator mod channel, evaluate with base, float inline base value, const faggregator evaluate parameters and parameters, const. Float multiplicative equals multiply mods, gameplay mod up, multiplicative, parameters, float division equals multiply mods, gameplay mod up, division, parameters. Return, inline base value plus additive, asterisk multiplicative, slash division, float faggregator mod channel, multiply mods, const tary faggregator mod, and in mods, const faggregator evaluate parameters and parameters, float multiplier equals 1.0 f, for, const faggregator mod and mod, in mods, if, mod, qualifies. Multiplier asterisk equals mod.evaluated magnitude, return multiplier, up arrow back to top 4.5.4.2 gameplay tags on modifier source tags and target tags can be set for each modifier. They work the same like the application tag requirements of a gameplay effect. So the tags are considered only when the effect is applied. I.e. when having a periodic, infinite effect, they are only taken into consideration on the first application of the effect but not on each periodic execution. Attribute-based modifiers can also set source tag filter and target tag filter. When determining the magnitude of the attribute which is the source of the attribute-based modifier, these filters are used to exclude certain modifiers to that attribute. Modifiers which source or target didn't have all of the tags of the filter are excluded. This means in detail, the tags of the source ASC and the target ASC are captured by gameplay effects. The source ASC tags are captured when the gameplay effect spec is created, the target ASC tags are captured on execution of the effect. When determining if a modifier of an infinite or duration effect qualifies to be applied, i.e. its aggregator qualifies, and those filters are set, the captured tags are compared against the filters. Up arrow back to top 4.5.5 stacking gameplay effects. Gameplay effects by default will apply new instances of the gameplay effect spec that don't know or care about previously existing instances of the gameplay effect spec on application. Gameplay effects can be set to stack where instead of a new instance of the gameplay effect spec is added, the currently existing gameplay effect spec stack count is changed. Stacking only works for duration and infinite gameplay effects. There are two types of stacking, aggregate by source and aggregate by target. Stacking type description aggregate by source. There is a separate instance of stacks per source ASC on the target. Each source can apply X amount of stacks. Aggregate by target. There is only one instance of stacks on the target regardless of source. Each source can apply a stack up to the shared stack limit. Stacks also have policies for expiration, duration refresh, and period reset. They have helpful hover tooltips in the gameplay effect blueprint. The sample project includes a custom blueprint node that listens for gameplay effect stack changes. The HUD UMG widget uses it to update the amount of passive armor stacks that the player has. This async task will live forever until manually called end task, which we do in the UMG widget's destruct event. See async task effect stack changed.h/cpp. Listen for gameplay effect stack change BP node. Up arrow back to top 4.5.6 granted abilities. Gameplay effects can grant new gameplay abilities to ASCs. Only duration and infinite gameplay effects can grant abilities. A common use case for this is when you want to force another player to do something like moving them from a knockback or pull. You would apply a gameplay effect to them that grants them an automatically activating ability. See passive abilities for how to automatically activate an ability when it is granted, that does the desired action to them. Designers can choose which abilities a gameplay effect grants, what level to grant them at, what input to bind them at, and the removal policy for the granted ability. Removal policy description. Cancel ability immediately. The granted ability is cancelled and removed immediately when the gameplay effect that granted it is removed from the target. Remove ability on end. The granted ability is allowed to finish and then is removed from the target. Do nothing. The granted ability is not affected by the removal of the granting gameplay effect from the target. The target has the ability permanently until it is manually removed later. Up arrow back to top 4.5.7 gameplay effect tags. Gameplay effects carry multiple gameplay tag containers. Designers will edit the added and removed gameplay tag containers for each category, and the result will show up in the combined gameplay tag container on compilation. Added tags are new tags that this gameplay effect adds that its parents did not previously have. Removed tags are tags that parent classes have but this subclass does not have. Category description gameplay effect asset tags that the gameplay effect has. They do not do any function on their own and serve only the purpose of describing the gameplay effect. Granted tags that live on the gameplay effect but are also given to the ASC that the gameplay effect is applied to. They are removed from the ASC when the gameplay effect is removed. This only works for duration and infinite gameplay effects. Ongoing tag requirements once applied, these tags determine whether the gameplay effect is on or off. A gameplay effect can be off and still be applied. If a gameplay effect is off due to failing the ongoing tag requirements, but the requirements are then met, the gameplay effect will turn on again and reapply its modifiers. This only works for duration and infinite gameplay effects. Application tag requirements tags on the target that determine if a gameplay effect can be applied to the target. If these requirements are not met, the gameplay effect is not applied. Remove gameplay effects with tags. Gameplay effects on the target that have any of these tags in their asset tags or granted tags will be removed from the target when this gameplay effect is successfully applied. Up arrow back to top 4.5.8 Immunity gameplay effects can grant immunity, effectively blocking the application of other gameplay effects, based on gameplay tags. While immunity can be effectively achieved through other means like application tag requirements, using this system provides a delegate for when gameplay effects are blocked due to immunity Ability system component, on immunity block gameplay effect delegate. Granted application immunity tags checks if the source ASC, including tags from the source abilities ability tags if there was one, has any of the specified tags. This is a way to provide immunity from all gameplay effects from certain characters or sources based on their tags. Granted application immunity query checks the incoming gameplay effect spec if it matches any of the queries to block or allow its application. The queries have helpful hover tooltips in the gameplay effect blueprint. Up arrow back to top 4.5.9 gameplay effect spec. The gameplay effect spec, G-spec, can be thought of as the instantiations of gameplay effects. They hold a reference to the gameplay effect class that they represent, what level it was created at, and who created it. These can be freely created and modified at runtime before application, unlike gameplay effects which should be created by designers prior to runtime. When applying a gameplay effect spec is created from the gameplay effect and that is actually what is applied to the target. Gameplay effect specs are created from gameplay effects using Ability system component, make outgoing spec, which is blueprint callable. Gameplay effect specs do not have to be immediately applied. It is common to pass a gameplay effect spec to a projectile created from an ability that the projectile can apply to the target it hits later. When gameplay effect specs are successfully applied, they return a new struct called fActive gameplay effect. Notable gameplay effect spec contents, the gameplay effect class that this gameplay effect was created from. The level of this gameplay effect spec. Usually the same as the level of the ability that created the gameplay effect spec but can be different. The duration of the gameplay effect spec. Defaults to the duration of the gameplay effect but can be different. The period of the gameplay effect spec for periodic effects. Defaults to the period of the gameplay effect but can be different. The current stack count of this gameplay effect spec. The stack limit is on the gameplay effect. The gameplay effect context handle tells us who created this gameplay effect spec. Attributes that were captured at the time of the gameplay effect spec's creation due to snapshotting. Dynamic granted tags that the gameplay effect spec grants to the target in addition to the gameplay tags that the gameplay effect grants. Dynamic asset tags that the gameplay effect spec has in addition to the asset tags that the gameplay effect has. Set by caller T-maps. Up arrow back to top 4.5.9. One set by callers allow the gameplay effect spec to carry float values associated with a gameplay tag or F name around. They are stored in their respective T-maps, T-map def gameplay tag, float and T-map def name, float on the gameplay effect spec. These can be used as modifiers on the gameplay effect or as generic means of ferrying floats around. It is common to pass numerical data generated inside of an ability to gameplay effect execution calculations or modifier magnitude calculations via set by callers. Set by caller use notes modifiers must be defined ahead of time in the gameplay effect class. Can only use the gameplay tag version. If one is defined on the gameplay effect class but the gameplay effect spec does not have the corresponding tag and float value pair, the game will have a runtime error on application of the gameplay effect spec and return 0. This is a potential problem for a divide operation. See modifiers. Elsewhere does not need to be defined ahead of time anywhere. Reading a set by caller it does not exist on a gameplay effect spec can return a developer-defined default value with optional warnings. To assign set by caller values in Blueprint, use the Blueprint node for the version that you need, gameplay tag or fname assigning set by caller to read a set by caller value in Blueprint, you will need to make custom nodes in your Blueprint library. To assign set-by-caller values in C++, use the version of the function that you need, gameplay tag or fname void fgameplay effect spec, set by caller magnitude, fname data name, float magnitude, void fgameplay effect spec, set by caller magnitude, fgameplay tag data tag, float magnitude. To read a set-by-caller value in C++, use the version of the function that you need, gameplay tag or fname float get set-by-caller magnitude, fname data name, bool warn if not found equals true, float default if not found equals 0.f. Const, float get set-by-caller magnitude, fgameplay tag data tag, bool warn if not found equals true, float default if not found equals 0.f, const. I recommend using the gameplay tag version over the fname version. This can prevent spelling errors in Blueprint. Up arrow back to top April 5th, 10 gameplay effect context. The gameplay effect context structure holds information about a gameplay effect spec's instigator and target data. This is also a good structure to subclass to pass arbitrary data around between places like modifier magnitude calculations / gameplay effect execution calculations, attribute sets, and gameplay queues. To subclass the gameplay effect context, subclass fgameplay effect context override fgameplay effect context, getScript struct, override fgameplay effect context, duplicate, override fgameplay effect context, net serialize. If your new data needs to be replicated, implement tstruct obstype traits for your subclass. Like the parent struct fgameplay effect context has override alloc gameplay effect context. In your ability system globals class to return a new object of your subclass JS shooter uses a subclass gameplay effect context to add target data which can be accessed in gameplay queues, specifically for the shotgun since it can hit more than one enemy. Up arrow back to top April 5th, 11 modifier magnitude calculations, mod mag calc or MMC, are powerful classes used as modifiers in gameplay effects. They function similarly to gameplay effect execution calculations but are less powerful and most importantly they can be predicted. Their sole purpose is to return a float value from calculate base magnitude _ implementation. You can subclass and override this function in Blueprint and C++. MMCs can be used in any duration of gameplay effects, instant, duration, infinite, or periodic. MMC's strength lies in their capability to capture the value of any number of attributes on the source or the target of gameplay effect with full access to the gameplay effect spec to read gameplay tags and set-by-callers. Attributes can either be snapshot or not. Snapshot attributes are captured when the gameplay effect spec is created, whereas non-snapshot attributes are captured and the gameplay effect spec is applied and automatically update when the attribute changes for infinite and duration gameplay effects. Capturing attributes recalculates their current value from existing mods on the ASC. This recalculation will not run pre-attribute change in the ability set, so any clamping must be done here again. Snapshot source or target captured on gameplay effect spec automatically updates when attribute changes for infinite or duration. Yes source creation, no. Yes target application, no. No source application, yes. No target application, yes. The resultant float from an MMC can further be modified in the gameplay effects modifier by a coefficient and a pre and post coefficient addition. An example MMC that captures the target's mana attribute reduces it from a poison effect, or the amount reduced changes depending on how much mana the target has and a tag that the target might have. This code defines a gameplay effect modifier calculation, MMC, class a PAM_poison mana that calculates a mana reduction effect based on the target's current and maximum mana, as well as specific gameplay tags. 1. A PAM_poison mana constructor captures two attributes from UP attribute set base, mana def, current mana, max mana def, maximum mana, attribute source. The captured attributes come from the target, E gameplay effect attribute capture source, target. B snapshot, false means the attributes will be dynamically evaluated rather than captured at the moment the effect is applied. Stores captured attributes in relevant attributes to capture. 2. Calculate base magnitude _ implementation. This function calculates the magnitude of the mana reduction effect. Steps: get source and target tags, extracts gameplay tags from both the source, captured source tags, and the target, captured target tags. Setup evaluation parameters creates an F-aggregator evaluate parameters instance to pass source and target tags into calculations. Capture and clamp mana values retrieves current mana and ensures it's at least 0.0 F. Retrieves max mana and ensures it's at least 1.0 F, to avoid division by 0. Apply base reduction. The base mana reduction is -20.0 F. Conditional multipliers: if the target has more than 50% of their mana, the reduction effect doubles, reduction * equals 2. If the target has the tag status.weak to poison mana, the reduction effect doubles again, reduction * equals 2. Summary: captures and evaluates the target's mana and max mana. Applies a base mana reduction of -20.0 F. Doubles the effect if the target has more than 50% mana. The target has the weak to poison mana tag. This ensures that the poison mana effect scales dynamically based on the target state. If you don't add the F-gameplay effect attribute capture definition to relevant attributes to capture in the MMC's constructor and try to capture attributes, you will get an error about a missing spec while capturing. If you don't need to capture attributes, then you don't have to add anything to relevant attributes to capture. Up arrow back to top April 5th, 12 gameplay effect execution calculation. Gameplay effect execution calculations, execution calculation, execution. You will often see this term in the plugin source code, or exec_calc, are the most powerful way for gameplay effects to make changes to an ASC. Like modifier magnitude calculations, these can capture attributes and optionally snapshot them. Unlike MMCs, these can change more than one attribute and essentially do anything else that the programmer wants. The downside to this power and flexibility is that they cannot be predicted and they must be implemented in C++. Execution calculations can only be used with instant and periodic gameplay effects. Anything with the word execute in it typically refers to these two types of gameplay effects. Snapshotting captures the attribute when the gameplay effect spec is created, whereas not snapshotting captures the attribute when the gameplay effect spec is applied. Capturing attributes recalculates their current value from existing mods on the ASC. This recalculation will not run pre-attribute change in the ability set, so any clamping must be done here again. Snapshot source or target captured on gameplay effect spec. Yes, source creation. Yes, target application. No, source application. No, target application. To set up attribute capture, we follow a pattern set by Epic's Action RPG sample project by defining a struct holding and defining how we capture the attributes and creating one copy of it in a structs constructor. You will have a struct like this for every exec_calc. Note, each struct needs a unique name as they share the same namespace. Using the same name for the structs will cause incorrect behavior in capturing your attributes, mostly capturing the values of the wrong attributes. For local predicted, server only, and server initiated gameplay abilities, the exec_calc only calls on the server. Calculating damage received based on a complex formula reading from many attributes on the source and the target is the most common example of an exec_calc. The included sample project has a simple exec_calc for calculating damage that reads the value of damage from the gameplay effect spec set by caller and then mitigates that value based on the armor attribute captured from the target. See GD damage exec calculation.cpp/.h. Up arrow back to top 4.5.12.1 Sending data to execution calculations. There are a few ways to send data to an execution calculation in addition to capturing attributes. 4.5.12.1.1 Set by caller. Any set by caller set on the gameplay effect spec can be directly read in the execution calculation. Const f gameplay effect spec and spec equals execution prims.get owning spec, float damage equals f math, max float, spec.get set by caller magnitude, f gameplay tag. Request gameplay tag, f name, data, damage, false, -1.0f, 0.0f, 4.5.12.1.2 Backing data attribute calculation modifier. If you want to hardcode values to a gameplay effect, you can pass them in using a calculation modifier that uses one of the captured attributes as the backing data. In this screenshot example, we're adding 50 to the captured damage attribute. You could also set this to override to just take in only the hard-coded value. Backing data attribute calculation modifier. The execution calculation reads this value in when it captures the attribute. Float damage equals 0.0f, / capture optional damage value set on the damage GE as a calculation modifier under the execution calculation execution prims. Attempt calculate captured attribute magnitude, damage statics, damage def, evaluation parameters, damage. 4.5.12.1.3 Backing data temporary variable calculation modifier. If you want to hardcode values to a gameplay effect, you can pass them in using a calculation modifier that uses a temporary variable or transient aggregator as it's called in C++. The temporary variable is associated with a gameplay tag. In this screenshot example, we're adding 50 to a temporary variable using the data damage gameplay tag. Backing data temporary variable calculation modifier. Add backing temporary variables to your execution calculations constructor. Valid transient aggregator identifiers. Add tag, f gameplay tag, request gameplay tag, data, damage. The execution calculation reads this value in using special capture functions similar to the attribute capture functions. Float damage equals 0.0f, execution prims. Attempt calculate transient aggregator magnitude, f gameplay tag, request gameplay tag, data, damage, evaluation parameters, damage, 4.5.12.1.4 gameplay effect context. You can send data to the execution calculation via custom gameplay effect context on the gameplay effect spec. In the execution calculation you can access the effect context from the f gameplay effect custom execution parameters. Const f gameplay effect spec and spec equals execution prims. Get owning spec, fgs gameplay effect context * context handle equals static _ cast fgs gameplay effect context * spec.get context. Get, if you need change something on the gameplay effect spec or the effect context. F gameplay effect spec * mutable spec equals execution prims. Get owning spec for pre-execute mod, fgs gameplay effect context * context handle equals static _ cast fgs gameplay effect context * mutable spec - get context. Get, use caution if modifying the gameplay effect spec in the execution calculation. See the comment for get owning spec for pre-execute mod. *** non-const access. Be careful with this, especially when modifying a spec after attribute capture. /f gameplay effect spec get owning spec for pre-execute mod, const, up arrow back to top April 5th, 13 custom application requirement CR, classes give the designers advanced control over whether a gameplay effect can be applied versus the simple gameplay tag checks on the gameplay effect. These can be implemented in Blueprint by overriding CanApply gameplay effect, and in C++ by overriding CanApply gameplay effect _ implementation. Examples of when to use CARs: target needs to have a certain amount of an attribute, target needs to have a certain number of stacks of a gameplay effect. CRs can also do more advanced things like checking if an instance of this gameplay effect is already on the target and changing the duration of the existing instance instead of applying a new instance, return false for CanApply gameplay effect. Up arrow back to top April 5th, 14 cost gameplay effect. Gameplay abilities have an optional gameplay effect specifically designed to use as the cost of the ability. Costs are how much of an attribute an ASC needs to have to be able to activate the gameplay ability. If a GA cannot afford the cost GE, then they will not be able to activate. This cost GE should be an instant gameplay effect with one or more modifiers that subtract from attributes. By default, cost GEs are meant to be predicted, and it is recommended to maintain that capability, meaning do not use execution calculations. MMCs are perfectly acceptable and encouraged for complex cost calculations. When starting out, you will most likely have one unique cost GE per GA that has a cost. A more advanced technique is to reuse one cost GE from multiple GAs and just modify the gameplay effect spec created from the cost GE with the GA-specific data. The cost value is defined on the GA. This only works for instanced abilities. 2 techniques for reusing the cost GE. Use an MMC. This is the easiest method. Create an MMC that reads the cost value from the gameplay ability instance, which you can get from the gameplay effect spec. Float UPG MMC underscore hero ability cost, calculate base magnitude underscore implementation, const F gameplay effect spec and spec, const UPG gameplay ability asterisk ability equals cast UPG gameplay ability, spec dot get context, dot get ability instance underscore not replicated, if, ability, return 0.0 F, return ability dash, cost dot get value at level, ability dash get ability level. In this example the cost value is an F scalable float on the gameplay ability child class that I added to it. A property, blueprint read only, edit anywhere, category equals, cost, F scalable float cost GE with MMC override U gameplay ability, get cost gameplay effect. Override this function and create a gameplay effect at runtime that reads the cost value on the gameplay ability. Up arrow back to top April 5th, 15 cooldown gameplay effect. Gameplay abilities have an optional gameplay effect specifically designed to use as the cooldown of the ability. Cooldowns determine how long after activation the ability can be activated again. If a GA is still on cooldown, it cannot activate. This cooldown GE should be a duration gameplay effect with no modifiers and a unique gameplay tag per gameplay ability or per ability slot, if your game has interchangeable abilities assigned to slots that share a cooldown. In the gameplay effects granted tags, cooldown tag. The GA actually checks for the presence of the cooldown tag instead of the presence of the cooldown GE. By default, cooldown GEs are meant to be predicted, and it is recommended to maintain that capability, meaning do not use execution calculations. MMCs are perfectly acceptable and encouraged for complex cooldown calculations. When starting out, you will most likely have one unique cooldown GE per GA that has a cooldown. A more advanced technique is to reuse one cooldown GE from multiple GAs and just modify the gameplay effect spec created from the cooldown GE with the GA-specific data. The cooldown duration and the cooldown tag are defined on the GA. This only works for instanced abilities. 2 techniques for reusing the cooldown GE. Use a setByCaller. This is the easiest method. Set the duration of your shared cooldown GE to setByCaller with a gameplay tag. On your gameplay ability subclass, define a float/F scalable float for the duration, a F gameplay tag container for the unique cooldown tag, and a temporary F gameplay tag container that we will use as the return pointer of the union of our cooldown tag and the cooldown GE's tags. This code extends U gameplay ability to customize ability cooldowns by merging cooldown tags and dynamically applying a cooldown effect. Key components. 1. Cooldown properties. Cooldown duration. F scalable float defines the cooldown time, which scales with ability level. Cooldown tags. F gameplay tag container stores cooldown related tags for the ability. Temp cooldown tags. F gameplay tag container, transient, a temporary container used to combine cooldown tags from the ability and its cooldown effect. 2. Overriding get cooldown tags, returns a combined set of cooldown tags from the parent ability's cooldown tags, super, get cooldown tags. This ability's cooldown tags. Clears temp cooldown tags before appending new tags to prevent issues with class default object, CDO. Data persistence. 3. Overriding apply cooldown, retrieves the cooldown effect, cooldown G, using get cooldown gameplay effect. Creates a gameplay effect spec handle, adds cooldown tags to dynamic granted tags, ensuring cooldown tags persist when applied. Uses setByCaller magnitude to dynamically set the cooldown duration in the effect. Applies the effect to the ability owner using apply gameplay effect spec to owner. Summary, tracks cooldown tags in cooldown tags. Merges cooldown tags with existing cooldown effects in get cooldown tags. Applies the cooldown effect dynamically, setting its duration based on cooldown duration. This ensures cooldowns are customizable, scalable, and dynamically applied in Unreal's gameplay ability system, GAS. Finally, override U gameplay ability, apply cooldown, to inject our cooldown tags and to add the setByCaller to the cooldown gameplay effect spec. Void UPG gameplay ability, apply cooldown, const F gameplay ability spec handle, const F gameplay ability actor info asterisk actor info, const F gameplay ability activation info, const U gameplay effect asterisk cooldown GE equals get cooldown gameplay effect, if, cooldown GE, F gameplay effect spec handle equals make outgoing gameplay effect spec, cooldown GE dash get class, get ability level, spec handle, data, get, dash dynamic granted tags dot append tags, cooldown tags, spec handle, data, get, dash. SetByCaller magnitude, F gameplay tag, request gameplay tag, F name, our setByCaller tag, cooldown duration. Get value at level, get ability level, apply gameplay effect spec to owner, handle, actor info, activation info, spec handle. In this picture, the cooldown's duration modifier is set to setByCaller with a data tag of data, cooldown. Data, cooldown would be our setByCaller tag in the code above. Cooldown GE with setByCaller use an MMC. This has the same setup as above except for setting the setByCaller as the duration on the cooldown GE and in apply cooldown. Instead, set the duration to be a custom calculation class and point to the new MMC that we will make. A property, blueprint read only, edit anywhere, category equals, cooldown, f scalable float cooldown duration, a property, blueprint read only, edit anywhere, category equals, cooldown, f gameplay tag container cooldown tags, / temp container that we will return the pointer to and get cooldown tags. / this will be a union of our cooldown tags and the cooldown GE's cooldown tags. Overview. This code enhances gameplay ability system, GAS, cooldown management by dynamically applying cooldown effects, calculating cooldown durations, and retrieving remaining cooldown time. 1. Get cooldown tags, overrides gameplay ability, combines cooldown tags from, parent ability, super, get cooldown tags. This ability's cooldown tags. Uses temp cooldown tags, transient, to avoid persistent modifications on the CDO. Clears temp cooldown tags before appending new tags. 2. Apply cooldown, overrides gameplay ability, retrieves the cooldown effect, cooldown GE. Creates a gameplay effect spec to apply the cooldown. Adds cooldown tags to dynamic granted tags, ensuring cooldowns are tracked. Applies the effect to the owner via apply gameplay effect spec to owner. 3. Calculate base magnitude _ implementation, overrides gameplay mod magnitude calculation, extracts the ability instance from the effect spec. Returns the ability's cooldown duration based on its level. Ensures cooldown duration scales dynamically with the ability's level. 4. Get cooldown remaining for tag, in APG player state, queries the active effects using cooldown tags to check if any cooldowns match. Retrieves remaining time and total cooldown duration for the longest active cooldown. Returns true if a cooldown is found, otherwise false. Summary. Get cooldown tags, returns merged cooldown tags. Apply cooldown, applies cooldown effects dynamically. Calculate base magnitude _ implementation. Determines cooldown duration based on ability level. Get cooldown remaining for tag, finds and retrieves active cooldown durations. This system ensures cooldowns are scalable, trackable, and efficiently applied in GAS. Note, querying the cooldown's time remaining on clients requires that they can receive replicated gameplay effects. This will depend on their ASC's replication mode. For .5.15.2 listening for cooldown begin and end. To listen for when a cooldown begins, you can either respond to when the cooldown GE is applied by binding to ability system component - on active gameplay effect added delegate to self, or when the cooldown tag is added by binding to ability system component - register gameplay tag event, cooldown tag, gameplay tag event type, new or removed. I recommend listening for when the cooldown GE is added because you also have access to the gameplay effect spec that applied it. From this you can determine if the cooldown GE is the locally predicted one or the server's correcting one. To listen for when a cooldown ends, you can either respond to when the cooldown GE is removed by binding to ability system component - on any gameplay effect remove delegate, or when the cooldown tag is removed by binding to ability system component - register gameplay tag event, cooldown tag, gameplay tag event type, new or removed. I recommend listening for when the cooldown tag is removed because when the server's corrected cooldown GE comes in, it will remove our locally predicted one, causing the on any gameplay effect remove delegate to fire even though we're still on cooldown. The cooldown tag will not change during the removal of the predicted cooldown GE and the application of the server's corrected cooldown GE. Note, listening for a gameplay effect to be added or removed on clients requires that they can receive replicated gameplay effects. This will depend on their ASC's replication mode. The sample project includes a custom blueprint node that listens for cooldowns beginning and ending. The HUD UMG widget uses it to update the amount of time remaining on the meteor's cooldown. This async task will live forever until manually called end task, which we do in the UMG widget's destruct event. See async task cooldown changed.h/cpp. Listen for cooldown change BP node 4.5.15.3 predicting cooldowns. Cooldowns cannot really be predicted currently. We can start UI cooldown timers when the locally predicted cooldown GE is applied but the gameplay ability's actual cooldown is tied to the server's cooldown's time remaining. Depending on the player's latency, the locally predicted cooldown could expire but the gameplay ability would still be on cooldown on the server, and this would prevent the gameplay ability's immediate reactivation until the server's cooldown expires. The sample project handles this by graying out the meteor ability's UI icon when the locally predicted cooldown begins and then starting the cooldown timer once the server's corrected cooldown GE comes in. A gameplay consequence of this is that players with high latencies have a lower rate of fire on short cooldown abilities than players with lower latencies, putting them at a disadvantage. Fortnite avoids this by their weapons having custom bookkeeping that do not use cooldown gameplay effects. Allowing for true predicted cooldowns, player could activate a gameplay ability when the local cooldown expires but the server is still on cooldown, is something that Epic would like to implement someday in a future iteration of GAS. Up arrow back to top April 5th, 16 changing active gameplay effect duration to change the time remaining for a cooldown GE or any duration gameplay effect. We need to change the gameplay effect specs duration, update its start server world time, update its cache start server world time, update its start world time, and rerun the check on the duration with check duration. Doing this on the server and marking the active gameplay effect dirty will replicate the changes to clients. Note, this does involve a const_cast and may not be Epic's intended way of changing durations, but it seems to work well so far. Overview: this function, set gameplay effect duration handle, modifies the duration of an active gameplay effect, GE, in Unreal Engine's gameplay ability system, GAS. Step-by-step breakdown: validate the handle returns false if the provided active gameplay effect handle is invalid. Retrieve the active gameplay effect, AGE, calls getActiveGameplayEffect, handle. Returns false if the GE is not found. Modify the duration if new duration is 0, update spec, duration with new duration. Else, set spec, duration to 0.01f, likely to prevent division by 0 or ensure instant removal. Update timing information: update start server world time and cache start server world time using ActiveGameplayEffects.getServerWorldTime. Update start world time using ActiveGameplayEffects.getWorldTime. Mark effect as dirty: calls ActiveGameplayEffects.markItemDirty, *AGE, ensuring replication updates. Check if effect should expire: calls ActiveGameplayEffects.checkDuration, handle, to verify if the effect should still be active. Broadcast time change event: calls AGE-eventSet.onTimeChanged, broadcast, notifying any listeners about the duration change. Trigger gameplay effect duration change notification: calls on gameplay effect duration change, *AG, which might handle UI updates or gameplay logic. Summary: dynamically modifies an active gameplay effect's duration. Ensures proper timing updates and replication. Notifies systems about the duration change via event broadcasting. This function is useful for extending, reducing, or dynamically adjusting buff/debuff durations during gameplay. Rocket up arrow back to top April 5th, 17 creating dynamic gameplay effects at runtime. Creating dynamic gameplay effects at runtime is an advanced topic. You shouldn't have to do this too often. Only instant gameplay effects can be created at runtime from scratch in C++. Duration and infinite gameplay effects cannot be created dynamically at runtime because when they replicate they look for the gameplay effect class definition that does not exist. To achieve this functionality, you should instead make an archetype gameplay effect class like you would normally do in the editor. Then customize the gameplay effect spec instance with what you need at runtime. Instant gameplay effects created at runtime can also be called from within a local predicted gameplay ability. However, it is unknown yet if the dynamic creation can have side effects. Key takeaways: instant GEs apply effects immediately and do not persist. Modifiers dynamically adjust XP, gold, or attributes. Manually creating gameplay effect spec prevents GAS from overriding the effect. Jumping, sprinting, shooting a gun, passively blocking an attack every X number of seconds, using a potion, opening a door, collecting a resource, constructing a building. Things that should not be implemented with gameplay abilities. Basic movement input, some interactions with UIs. Don't use a gameplay ability to purchase an item from a store. These are not rules, just my recommendations. Your design and implementations may vary. Gameplay abilities come with default functionality to have a level to modify the amount of change to attributes or to change the gameplay abilities functionality. Gameplay abilities run on the owning client and/or the server depending on the net execution policy but not simulated proxies. The net execution policy determines if a gameplay ability will be locally predicted. They include default behavior for optional cost and cooldown gameplay effects. Gameplay abilities use ability tasks for actions that happen over time, like waiting for an event, waiting for an attribute change, waiting for players to choose a target, or moving a character with root motion source. Simulated clients will not run gameplay abilities. Gameplay ability specs are replicated from the server to the owning client by default. As mentioned above, gameplay abilities don't run on simulated proxies. They use ability. To bind input to an ASC, you must first create an enum that translates the input action name to a byte. The enum name must match exactly to the name used for the input action in the project settings. The display name does not matter. From the sample project, the EGD ability input ID enum defines input IDs for abilities, e.g., ability 1 for LMB, jump for jumping. In setup player input component, the ASC is bound to the player's input using bind ability activation to input component, with the EGD ability input ID enum mapping inputs to ability activations. If your ASC lives on the player state, there is a potential race condition inside of setup player input component, where the player state may not have replicated to the client yet. Therefore, I recommend attempting to bind to input in setup player input component and onRep_player state. OnRep_player state is not sufficient by itself because there could be a case where the actor's input component could be null when player state replicates before the player controller tells the client to call client restart, which creates the input component. The sample project demonstrates attempting to bind in both locations with a boolean gating the process so it only actually binds the input once. Note, in the sample project, confirm and cancel in the enum don't match the input action names in the project settings, confirm target and cancel target, but we supply the mapping between them in bind ability activation to input component. These are special since we supply the mapping. They don't have to match, but they can match. All other inputs in the enum must match the input action names in the project settings. For gameplay abilities that will only ever be activated by one input, they will always exist in the same slot, like a MOBA. I prefer to add a variable to my gameplay ability subclass where I can define their input. I can then read this from the class default object when granting the ability. 4.6.2 1. Binding to input without activating abilities. If you don't want your gameplay abilities to automatically activate when an input is pressed but still bind them to input to use with ability tasks, you can add a new bool variable to your gameplay ability subclass, activate on input, that defaults to true and override this function. UGS ability system component, ability local input pressed, handles input events for abilities in Unreal Engine's gameplay ability system, GAS. How it works: handle generic confirm/cancel input, checks if the input ID is overloaded with a generic confirm, local input confirm, or cancel, local input cancel, action. If so, it consumes the input and stops further processing. Process ability inputs, locks the ability list _scope_lock, to safely iterate over activatable abilities. Loops through all abilities and activatable abilities, items and matches the input ID, if input pressed is true and the ability is active, replicates input if required, server set input pressed. Notifies the ability using ability spec input pressed and broadcasts the input pressed event. If the ability is not active, checks if the ability is set to activate on input, activate on input. If so, tries to activate the ability via try activate ability. Summary: this function handles ability input events by either confirming/canceling generic actions or processing specific ability inputs. If the ability is inactive and set to activate on input, it tries to activate it. Up arrow back to top 4.6.3 Granting abilities. Granting a gameplay ability to an ASC adds it to the ASC's list of activatable abilities, allowing it to activate the gameplay ability at will if it meets the gameplay tag requirements. We grant gameplay abilities on the server, which then automatically replicates the gameplay ability spec to the owning client. Other client/simulated proxies do not receive the gameplay ability spec. The sample project stores a TerraET subclass of UGD gameplay ability on the character class that it reads from and grants when the game starts. Void AGD character base, add character abilities, / grant abilities, but only on the server if role equals role_authority, ability system component is valid, ability system component -b character abilities given, return, for T subclass of UGD gameplay ability, and startup ability, character abilities, ability system component -give ability, F gameplay ability spec, startup ability. Get ability level, startup ability.get default object, ability ID, static_cast int 32, startup ability.get default object, ability input ID. This, ability system component -b character abilities given equals true. When granting these gameplay abilities, we're creating gameplay ability specs with the gameplay ability class, the ability level, the input that it is bound to, and the source object or who gave this gameplay ability to this ASC. Up arrow back to top 4.6.4 Activating abilities. If a gameplay ability is assigned an input action, it will be automatically activated if the input is pressed and it meets its gameplay tag requirements. This may not always be the desirable way to activate a gameplay ability. The ASC provides 4 other methods of activating gameplay abilities: by gameplay tag, gameplay ability class, gameplay ability spec handle, and by an event. Activating a gameplay ability by event allows you to pass in a payload of data with the event. A function, blueprint callable, category equals, abilities, bool try activate abilities by tag, const f gameplay tag container and gameplay tag container, bool BLR remote activation equals true. A function, blueprint callable, category equals, abilities, bool try activate ability by class, T subclass of gameplay ability, inability to activate, bool BLR remote activation equals true. Bool try activate ability, f gameplay ability spec handle ability to activate, bool BLR remote activation equals true. Bool trigger ability from gameplay event, f gameplay ability spec handle ability to trigger, f gameplay ability actor info *actor info, f gameplay tag, const f gameplay event data * payload, u ability system component and component, f gameplay ability spec handle give ability and activate once, const f gameplay ability spec and ability spec, const f gameplay event data * gameplay event data. To activate a gameplay ability by event, the gameplay ability must have its triggers set up in the gameplay ability. Assign a gameplay tag and pick an option for gameplay event. To send the event, use the function uAbilitySystem Blueprint Library, send gameplay event to actor, actor, *actor, f gameplay tag event tag, f gameplay event data payload. Activating a gameplay ability by event allows you to pass in a payload with data. Gameplay ability triggers also allow you to activate the gameplay ability when a gameplay tag is added or removed. Note, when activating a gameplay ability from event in Blueprint, you must use the activate ability from event node. Note, don't forget to call end ability, when the gameplay ability should terminate unless you have a gameplay ability that will always run like a passive ability. Activation sequence for locally predicted gameplay abilities: owning client calls try activate ability, calls internal try activate ability, calls can activate ability, and returns whether gameplay tag requirements are met, if the ASC can afford the cost, if the gameplay ability is not on cooldown, and if no other instances are currently active. Calls call server try activate ability, and passes it the prediction key that it generates. Calls call activate ability, calls pre-activate, epic refers to this as boilerplate init stuff. Calls activate ability, finally activating the ability. Server receives call server try activate ability, calls server try activate ability, calls internal server try activate ability, calls internal try activate ability, calls can activate ability. and returns whether gameplay tag requirements are met, if the ASC can afford the cost, if the gameplay ability is not on cooldown, and if no other instances are currently active. Calls client activatability succeed, if successful, telling it to update its activation info that its activation was confirmed by the server and broadcasting the onConfirm delegate. This is not the same as input confirmation. Calls call activatability, calls pre-activate, Epic refers to this as boilerplate in its stuff. Calls activatability, finally activating the ability. If at any time the server fails to activate, it will call client activatability failed, immediately terminating the client's gameplay ability and undoing any predicted changes. 4.6.4.1 Passive abilities. To implement passive gameplay abilities that automatically activate and run continuously, override gameplay ability on avatar set, which is automatically called when a gameplay ability is granted and the avatar actor is set, and call try activatability. I recommend adding a bool to your custom gameplay ability class specifying if the gameplay ability should be activated when granted. The sample project does this for its passive armor stacking ability. Passive gameplay abilities will typically have a net execution policy of server only. Void UGD gameplay ability, on avatar set, const F gameplay ability actor info asterisk actor info, const F gameplay ability spec and spec, super, on avatar set, actor info, spec, if, B activate ability on granted, actor info dash ability system component dash try activate ability, spec, handle, false. Epic describes this function as the correct place to initiate passive abilities and to do begin play type things. Up arrow back to top 4.6.4.2 activation failed tags. Abilities have default logic to tell you why an ability activation failed. To enable this, you must set up the gameplay tags that correspond to the default failure cases. Add these tags, or your own naming convention, to your project, plus gameplay tag list sad face tag equals activation, failed.blocked by tags dev comment equals, plus gameplay tag list sad face tag equals activation, failed.can't afford cost dev comment equals, plus gameplay tag list sad face tag equals activation, failed.is dead dev comment equals, plus gameplay tag list sad face tag equals activation, failed.missing tags dev comment equals, plus gameplay tag list sad face tag equals activation, fail, networking dev comment equals. Plus gameplay tag list sad face tag equals activation, failed.on cooldown dev comment equals, then add them to the GAS documentation /config /default game.ini /script /gameplay ability system globals, activate fail is dead name equals activation, fail.is dead activate fail cooldown name equals activation. Fail.on cooldown activate fail cost name equals activation, fail.can't afford cost activate fail tags block name equals activation, fail.blocked by tags activate fail tags missing name equals activation, fail.missing tags activate fail networking name equals activation, fail, networking. Now whenever an ability activation fails, this corresponding gameplay tag will be included in output log messages or visible on the show debug ability system HUD. Log ability system, display, internal server try activate ability. Rejecting client activation of default __J fire gun _C. Internal try activate ability failed, activation, failed.blocked by tags log ability system, display, client activate ability failed implementation. Prediction key 109 ability. Default _J fire gun C activation failed tags displayed in show debug ability system. Up arrow back to top 4.6.5 canceling abilities. To cancel a gameplay ability from within, you call cancel ability. This will call end ability, and set its was cancelled parameter to true. To cancel a gameplay ability externally, the ASC provides a few functions, / cancels the specified ability CDO. /void cancel ability, gameplay ability / cancels the ability indicated by passed in spec handle. If handle is not found among reactivated abilities, nothing happens. /void cancel ability handle, const F gameplay ability spec handle and ability handle, /cancel all abilities with the specified tags. Will not cancel the ignore instance /void cancel abilities, const F gameplay tag container with tags equals nultre, const F gameplay tag container * without tags equals nultre, gameplay ability * ignore equals nultre, / cancels all abilities regardless of tags. Will not cancel the ignore instance /void cancel all abilities, gameplay ability ignore equals nultre. / cancels all abilities and kills any remaining instanced abilities * virtual void destroy active state. Note, I have found that cancel all abilities doesn't seem to work right if you have a non-instanced gameplay abilities. It seems to hit the non-instanced gameplay ability and give up. Cancel abilities can handle non-instanced gameplay abilities better, and that is what the sample project uses. Jump is a non-instanced gameplay ability. Your mileage may vary. Up arrow back to top 4.6.6 getting active abilities. Beginners often ask, how can I get the active ability, perhaps to set variables on it or to cancel it. More than one gameplay ability can be active at a time, so there is no one active ability. Instead, you must search through an ASC's list of activatable abilities, granted gameplay abilities that the ASC owns, and find the one matching the asset or granted gameplay tag that you are looking for. Ability system component, get activatable abilities, returns a tarif gameplay ability spec for you to iterate over. The ASC also has another helper function that takes in a gameplay tag container as a parameter to assist in searching instead of manually iterating over the list of gameplay ability specs. The B-only abilities that satisfy tag requirements parameter will only return gameplay ability specs that satisfy their gameplay tag requirements and could be activated right now. For example, you could have two basic attack gameplay abilities, one with a weapon and one with bare fists, and the correct one activates depending on if a weapon is equipped, setting the gameplay tag requirement. See Epic's comment on the function for more information. U ability system component, get activatable gameplay ability specs by all matching tags, const f gameplay tag container and gameplay tag container, terra struct f gameplay ability spec asterisk and matching gameplay abilities, bool b only abilities that satisfy tag requirements equals true. Once you get the f gameplay ability spec that you are looking for, you can call is active on it. Up arrow back to top 4.6.7 instancing policy. A gameplay ability's instancing policy determines if and how the gameplay ability is instanced when activated. Instancing policy description example of when to use instance per actor. Each ASC only has one instance of the gameplay ability that is reused between activations. See prediction. Server only. The gameplay ability is only run on the server. Passive gameplay abilities will typically be server only. Single player games should use this. Server initiated gameplay abilities activate first on the server and then on the owning client. I personally haven't used these much if any. Up arrow back to top 4.6.9 ability tags. Gameplay abilities come with gameplay tag containers with built-in logic. None of these gameplay tags are replicated. Gameplay tag container description ability tags. Gameplay tags that the gameplay ability owns. These are just gameplay tags to describe the gameplay ability. Cancel abilities with tag. Other gameplay abilities that have these gameplay tags in their ability tags will be cancelled when this gameplay ability is activated. Block abilities with tag. Other gameplay abilities that have these gameplay tags in their ability tags are blocked from activating while this gameplay ability is active. Activation own tags. These gameplay tags are given to the gameplay ability's owner while this gameplay ability is active. Remember, these are not replicated. Activation required tags. This gameplay ability can only be activated if the owner has all of these gameplay tags. Activation blocked tags. This gameplay ability cannot be activated if the owner has any of these gameplay tags. Source required tags. This gameplay ability can only be activated if the source has all of these gameplay tags. The source gameplay tags are only set if the gameplay ability is triggered by an event. Source blocked tags. This gameplay ability cannot be activated if the source has any of these gameplay tags. The source gameplay tags are only set if the gameplay ability is triggered by an event. Target required tags. This gameplay ability can only be activated if the target has all of these gameplay tags. The target gameplay tags are only set if the gameplay ability is triggered by an event. Target blocked tags. This gameplay ability cannot be activated if the target has any of these gameplay tags. The target gameplay tags are only set if the gameplay ability is triggered by an event. Up arrow back to top April 6th, 10 gameplay ability spec. A gameplay ability spec exists on the ASC after a gameplay ability is granted and defines the activatable gameplay ability class, level, input bindings, and runtime state that must be kept separate from the gameplay ability class. When a gameplay ability is granted on the server replicates the gameplay ability spec to the owning client so that she may activate it. Activating a gameplay ability spec will create an instance, or not for non-instanced gameplay abilities, of the gameplay ability depending on its instancing policy. Up arrow back to top April 6th, 11 passing data to abilities. The general paradigm for gameplay abilities is activate-generate data-apply-end. Sometimes you need to act on existing data. GAS provides a few options for getting external data into your gameplay abilities. Method description: activate gameplay ability by event. Activate a gameplay ability with an event containing a payload of data. The event's payload is replicated from client to server for local predicted gameplay abilities. Use the two optional object or the target data variables for arbitrary data that does not fit any of the existing variables. The downside to this is that it prevents you from activating the ability with an input bind. To activate a gameplay ability by event, the gameplay ability must have its triggers set up in the gameplay ability. Assign a gameplay tag and pick an option for gameplay event. To send the event, use the function uAbilitySystem Blueprint Library, send gameplay event to actor, 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 f gameplay tag event tag, f gameplay event data payload. Use wait gameplay event ability task. Use the wait gameplay event ability task to tell the gameplay ability to listen for an event with payload data after it activates. The event payload and the process to send it is the same as activating gameplay abilities by event. The downside to this is that events are not replicated by the ability task and should only be used for local only and server only gameplay abilities. You potentially could write your own ability task that will replicate the event payload. Use target data. A custom target data struct is a good way to pass arbitrary data between the client and server. Store data on the owner actor or avatar actor. Use replicated variables stored on the owner actor, avatar actor, or any other object that you can get a reference to. This method is the most flexible and will work with gameplay abilities activated by input binds. However, it does not guarantee the data will be synchronized from replication at the time of use. You must ensure that ahead of time, meaning if you set a replicated variable and then immediately activate a gameplay ability, there is no guarantee the order that will happen on the receiver due to potential packet loss. Up arrow back to top April 6th, 12 ability cost and cooldown. Gameplay abilities come with functionality for optional costs and cooldowns. Costs are predefined amounts of attributes that the ASC must have in order to activate the gameplay ability implemented with an instant gameplay effect, cost GE. Cooldowns are timers that prevent the reactivation of a gameplay ability until it expires and is implemented with a duration gameplay effect, cooldown GE. Before a gameplay ability calls uGameplay ability, activate, it calls uGameplay ability, can activate ability. This function checks if the owning ASC can afford the cost, uGameplayability, check cost, and ensures that the gameplayability is not on cooldown, uGameplayability, check cooldown. After a gameplayability calls activate, it can optionally commit the cost and cooldown at any time using uGameplayability, commitability, which calls uGameplayability, commit cost, and uGameplayability, commit cooldown. The designer may choose to call commit cost or commit cooldown separately if they shouldn't be committed at the same time. Committing cost and cooldown calls check cost and check cooldown one more time and is the last chance for the gameplayability to fail related to them. The owning ASC's attributes could potentially change after a gameplayability is activated, failing to meet the cost at time of commit. Committing the cost and cooldown can be locally predicted if the prediction key is valid at the time of commit. See cost GE and cooldown GE for implementation details. Up arrow back to top April 6, 13 leveling up abilities. There are two common methods for leveling up an ability. Level up method description ungrant and regrant at the new level ungrant, remove the gameplay ability from the ASC and regrant it back at the next level on the server. This terminates the gameplay ability if it was active at the time. Increase the gameplay ability spec's level on the server, find the gameplay ability spec, increase its level, and mark it dirty so that replicates to the owning client. This method does not terminate the gameplay ability if it was active at the time. The main difference between the two methods is if you want active gameplay abilities to be cancelled at the time of level up. You will most likely use both methods depending on your gameplay abilities. I recommend adding a bool to your uGameplay ability subclass specifying which method to use. Up arrow back to top April 6, 14 ability sets. Gameplay ability sets are convenience UData asset classes for holding input bindings and lists of startup gameplay abilities for characters with logic to grant the gameplay abilities. Subclasses can also include extra logic or properties. Paragon had a gameplay ability set per hero that included all of their given gameplay abilities. I find this class to be unnecessary, at least given what I've seen of it so far. The sample project handles all of the functionality of gameplay ability sets inside of the GD character base and its subclasses. Up arrow back to top April 6, 15 ability batching. Traditional gameplay ability lifecycle involves a minimum of 2 or 3 RPCs from the client to the server. Call server try activate ability, server set replicated target data, optional, server end ability. If a gameplay ability performs all of these actions in one atomic grouping in a frame, we can optimize this workflow to batch, combine, all 2 or 3 RPCs into one RPC. GAS refers to this RPC optimization as ability batching. The common example of when to use ability batching is for hitscan guns. Hitscan guns activate, do a line trace, send the target data to the server, and end the ability all in one atomic group in one frame. The GAS Shooter sample project demonstrates this technique for its hitscan guns. Semi-automatic guns are the best case scenario and batch the call server try activate ability, server set replicated target data, the bullet hit result, and server end ability, into one RPC instead of 3 RPCs. Full automatic /burst guns batch call server try activate ability, and server set replicated target data, for the first bullet into one RPC instead of 2 RPCs. Each subsequent bullet is its own server set replicated target data, RPC. Finally, server end ability is sent as a separate RPC when the gun stops firing. This is a worst-case scenario where we only save one RPC on the first bullet instead of 2. This scenario could have also been implemented with activating the ability via a gameplay event which would send the bullet's target data in with the event payload to the server from the client. The downside of the latter approach is that the target data would have to be generated externally to the ability, whereas the batching approach generates the target data inside of the ability. Ability batching is disabled by default on the ASC. To enable ability batching, override should do server ability RPC batch, to return true, virtual bool should do server ability RPC batch, const override, return true. Now that ability batching is enabled, before activating abilities that you want batched, you must create a fscope server ability RPC batcher struct beforehand. This special struct will try to batch any abilities following it within its scope. Once the fscope server ability RPC batcher falls out of scope, any abilities activated will not try to batch. Fscope server ability RPC batcher works by having special code in each of the functions that can be batched that intercepts the call from sending the RPC and instead packs the message into a batch struct. When fscope server ability RPC batcher falls out of scope, it automatically RPCs this batch struct to the server in uAbility system component, end server ability RPC batch. The server receives the batch RPC in uAbility system component, server ability RPC batch _internal, fserver ability RPC batch and batch info. The batch info parameter will contain flags for if the ability should end and if input was pressed at the time of activation and the target data if that was included. This is a good function to put a breakpoint on to confirm that your batching is working properly. Alternatively, use the kvar ability system.server RPC batching, log1 to enable special ability batching logging. This mechanism can only be done in C++ and can only activate abilities by their fgameplay ability spec handle. bool UGS ability system component, batch RPC try activate ability, F gameplay ability spec handle inability handle, bool end ability immediately, bool ability activated equals false, if, inability handle dot is valid, F scope server ability RPC batcher GS ability RPC batcher, this, inability handle, ability activated equals try activate ability, inability handle, true, if, end ability immediately, F gameplay ability spec asterisk ability spec equals find ability spec from handle, inability handle, if, ability spec. UGS gameplay ability asterisk GS ability equals cast UGS gameplay ability spec dash get primary instance, GS ability dash external end ability, return ability activated. Return ability activated, GAS shooter reuses the same batched gameplay ability for semi-automatic and full automatic guns which never directly call end ability, it is handled outside of the ability by a local-only ability that manages player input and a call to the batched ability based on the current fire mode. Since all of the RPCs must happen within the scope of the F-scope server ability RPC batcher, I provide the end ability immediately parameter so that the controlling/managing local only can specify whether this ability should batch the end ability, call, semi-automatic, or not batch the end ability, call, full automatic, and the end ability, call will happen sometime later in its own RPC. JS Shooter exposes a blueprint node to allow batching abilities which the aforementioned local only ability uses to trigger the batched ability. Activate batched ability up arrow back to top April 6, 16 Net Security Policy. A gameplay ability's net security policy determines where should an ability execute on the network. It provides protection from clients attempting to execute restricted abilities. Net security policy description: client or server, no security requirements. Client or server can trigger execution and termination of this ability freely. Server only execution: a client requesting execution of this ability will be ignored by the server. Clients can still request that the server cancel or end this ability. Server-only termination: a client requesting cancellation or ending of this ability will be ignored by the server. Clients can still request execution of the ability. Server-only server controls both execution and termination of this ability. A client making any requests will be ignored. Up arrow back to top 4.7 ability tasks. 4.7.1 ability task definition: gameplay abilities only execute in one frame. This does not allow for much flexibility on its own. To do actions that happen over time or require responding to delegates fired at some point later in time, we use latent actions called ability tasks. GAS comes with many ability tasks out of the box: tasks for moving characters with root motion source, a task for playing animation montages, tasks for responding to attribute changes, tasks for responding to gameplay effect changes, tasks for responding to player input, and more. The U ability task constructor enforces a hard-coded game-wide maximum of 1000 concurrent ability tasks running at the same time. Keep this in mind when designing gameplay abilities for games that can have hundreds of characters in the world at the same time, like RTS games. Up arrow back to top 4.7.2 custom ability tasks. Often you will be creating your own custom ability tasks in C++. The sample project comes with two custom ability tasks. Play montage and wait for event is a combination of the default play montage and wait gameplay event ability tasks. This allows animation montages to send gameplay events from anim notifies back to the gameplay ability that started them. Use this to trigger actions at specific times during animation montages. Wait receive damage listens for the owner actor to receive damage. The passive armor stacks gameplay ability removes a stack of armor when the hero receives an instance of damage. Ability tasks are composed of a static function that creates new instances of the ability task delegates that are broadcasted on when the ability task completes its purpose, and activate function to start its main job, bind to external delegates, etc. An onDestroy function for cleanup, including external delegates that it bound to callback functions for any external delegates that it bound to member variables and any internal helper functions. Note: ability tasks can only declare one type of output delegate. All of your output delegates must be of this type, regardless if they use the parameters or not. Pass default values for unused delegate parameters. Ability tasks only run on the client or server that is running the owning gameplay ability. However, ability tasks can be set to run on simulated clients by setting bSimulated_task equals true in the ability task constructor, overriding virtual void init simulated task, uGameplay tasks component and in-gameplay tasks component, and setting any member variables to be replicated. This is only useful in rare situations like movement ability tasks, where you don't want to replicate every movement change but instead simulate the entire movement ability task. All of the root motion source ability tasks do this. See ability task _move to location.h/.cpp as an example. Ability tasks can tick if you set bTicking task equals true in the ability task constructor and override virtual void tick task, float delta time. This is useful when you need to lerp values smoothly across frames. See ability task _move to location.h/.cpp as an example. Up arrow back to top 4.7.3 using ability tasks to create and activate an ability task in C++ from gdg_firegun.cpp ugdit_play montage and wait for event * task equals ugdit_play montage and wait for event play montage and wait for event this name _none montage to play f gameplay tag container 1.0 f name _none false 1.0 f task dash on blendout.add dynamic this and ugdg_firegun on completed task dash on completed.add dynamic this and ugdg_firegun on completed task dash on interrupted.add dynamic this and ugdg_firegun on cancelled. task-on-cancelled.add dynamic, this, and ugdg_firegun on-cancelled, task-event received.add dynamic, this, and ugdg_firegun event received, task-ready for activation. In Blueprint, we just use the blueprint node that we create for the ability task. We don't have to call ready for activation. That is automatically called by engine source editor /gameplay tasks editor /private /k2 node _ latent gameplay task call.cpp. K2 node _ latent gameplay task call also automatically calls begin spawning actor and finish spawning actor. If they exist in your ability task class, see ability task _ wait target data. To reiterate, K2 node _ latent gameplay task call only does automagic sorcery for Blueprint. In C++, we have to manually call ready for activation, begin spawning actor, and finish spawning actor. Blueprint wait target data ability task to manually cancel an ability task, just call end-task on the ability task object in Blueprint, called async task proxy, or in C++. Up arrow back to top 4.7.4 root motion source ability tasks. GAS comes with ability tasks for moving characters over time for things like knockbacks, complex jumps, pulls, and dashes using root motion sources hooked into the character movement component. Note, predicting root motion source ability tasks works up to engine version 4.19 and 4.25+. Prediction is bugged for engine versions 4.20 to 4.24, however, the ability tasks still perform their function in multiplayer with minor net corrections and work perfectly in single player. It is possible to cherry-pick the prediction fix from 4.25 into a custom 4.20 to 4.24 engine. Up arrow back to top 4.8 gameplay cues. 4.8.1 gameplay cue definition. Gameplay cues, GC, execute non-gameplay related things like sound effects, particle effects, camera shakes, etc. Gameplay cues are typically replicated, unless explicitly executed, added, or removed locally, and predicted. We trigger gameplay cues by sending a corresponding gameplay tag with the mandatory parent name of gameplay cue and an event type, execute, add, or remove, to the gameplay queue manager via the ASC. Gameplay queue notify objects and other actors that implement the iGameplay queue interface can subscribe to these events based on the gameplay queue's gameplay tag, gameplay queue tag. Note, just to reiterate, gameplay queue gameplay tags need to start with the parent gameplay tag of gameplay queue. So for example, a valid gameplay queue gameplay tag might be gameplay queue.a.b.c. There are two classes of gameplay queue notifies, static and actor. They respond to different events and different types of gameplay effects can trigger them. Override the corresponding event with your logic. Gameplay queue class event gameplay effect type description. Gameplay queue notify _ static execute instant or periodic. Static gameplay queue notifies operate on the class default object, meaning no instances, and are perfect for one-off effects like hit impacts. Gameplay queue notify _ actor add or remove duration or infinite actor. Gameplay queue notifies spawn a new instance when added. Because these are instanced, they can do actions over time until they are removed. These are good for looping sounds and particle effects that will be removed when the backing duration or infinite gameplay effect is removed or by manually calling remove. These also come with options to manage how many are allowed to be added at the same time so that multiple applications of the same effect only start the sounds or particles once. Gameplay queue notifies technically can respond to any of the events, but this is typically how we use them. Note, when using gameplay queue notify _ actor, check auto destroy on remove, otherwise subsequent calls to add that gameplay queue tag won't work. When using an ASC replication mode other than full, add and remove GC events will fire twice on server players, listen server, once for applying the GE and again from the minimal net multicast to the clients. However, while active events will still only fire once. All events will only fire once on clients. The sample project includes a gameplay queue notify _ actor for stun and sprint effects. It also has a gameplay queue notify _ static for the fire gun's projectile impact. These GCs can be optimized further by triggering them locally instead of replicating them through a GE. I opted for showing the beginner way of using them in the sample project. Up arrow back to top 4.8.2 triggering gameplay cues from inside of a gameplay effect, and it is successfully applied, not blocked by tags or immunity. Fill in the gameplay tags of all the gameplay cues that should be triggered. Gameplay cue triggered from a gameplay effect. This code provides methods for triggering gameplay cues from a gameplay ability system component, ASC, in Unreal Engine's gameplay ability system, GAS. Gameplay cue triggering methods. Execute gameplay cue triggers an instant cue, e.g., visual/audio effects. Can be called with either f-gameplay tag gameplay queue tag and f-gameplay effect context handle effect context. F-gameplay tag gameplay queue tag and f-gameplay queue parameters. Add gameplay queue applies a persistent gameplay queue, e.g., buffs, status effects. Can be called with f-gameplay effect context handle for context. F-gameplay queue parameters for more detailed data. Remove gameplay queue removes a previously applied gameplay queue identified by gameplay queue tag. Remove all gameplay cues clears all cues added outside of gameplay effects. Summary. Execute gameplay queue triggers one-time effects. Add gameplay queue activates persistent effects. Remove gameplay queue clears a specific queue. Remove all gameplay cues clears all non-gameplay effect cues. These functions allow abilities and effects to dynamically apply, trigger, and remove gameplay-related visual/audio effects efficiently in GAS. Rocket up arrow back to top 4.8.3 local gameplay cues. The exposed functions for firing gameplay cues from gameplay abilities and the ASC are replicated by default. Each gameplay cue event is a multicast RPC. This can cause a lot of RPCs. GAS also enforces a maximum of 2 of the same gameplay cue RPCs per net update. We avoid this by using local gameplay cues where we can. Local gameplay cues only execute, add, or remove on the individual client. Scenarios where we can use local gameplay cues: projectile impacts, melee collision impacts, gameplay cues fired from animation montages, local gameplay cue functions that you should add to your ASC subclass. This code defines 3 functions in UPA ability system component that handle local gameplay cues in Unreal Engine's gameplay ability system, GAS. 1. Execute gameplay cue local triggers an instant gameplay cue, e.g., visual or audio effects, using eGameplay cue event, executed. Calls handle gameplay cue on the gameplay cue manager, passing, the owner, get owner, of the ability system component. The gameplay cue tag, identifier for the cue. The gameplay cue parameters, contextual data. 2. Add gameplay cue local applies a persistent gameplay cue, eGameplay cue event, on active triggers when first applied. eGameplay cue event, while active, keeps the cue active while it remains valid. Useful for ongoing effects like status effects or buffs. 3. Remove gameplay cue local removes a previously applied gameplay cue using eGameplay cue event, removed. Ensures that visual/audio effects associated with the cue are properly cleared when the effect ends. Summary: execute gameplay cue local triggers an instant gameplay cue. Add gameplay cue local activates and maintains a gameplay cue. Remove gameplay cue local removes an active gameplay cue. These functions allow localized, non-replicated, execution of gameplay cues for efficient effect handling in GAS. Rocket: if a gameplay cue was added locally, it should be removed locally. If it was added via replication, it should be removed via replication. Up arrow back to top 4.8.4 gameplay cue parameters. Gameplay cues receive a gameplay cue parameters structure containing extra information for the gameplay cue as a parameter. If you manually trigger the gameplay cue from a function on the gameplay ability or the ASC, then you must manually fill in the gameplay cue parameters structure that is passed to the gameplay cue. If the gameplay cue is triggered by a gameplay effect, then the following variables are automatically filled in on the gameplay cue parameters structure. Aggregated source tags, aggregated target tags, gameplay effect level, ability level, effect context, magnitude. If the gameplay effect has an attribute for magnitude selected in the drop-down above the gameplay cue tag container and the corresponding modifier that affects that attribute. The source object variable in the gameplay cue parameters structure is potentially a good place to pass arbitrary data to the gameplay cue when triggering the gameplay cue manually. Note, some of the variables in the parameters structure like instigator might already exist in the effect context. The effect context can also contain a hit result for location of where to spawn the gameplay cue in the world. Subclassing effect context is potentially a good way to pass more data to gameplay cues, especially those triggered by a gameplay effect. See the 3 functions in Ability System Globals that populate the gameplay cue parameters structure for more information. They are virtual, so you can override them to auto-populate more information. / initialize gameplay cue parameters / virtual void init gameplay cue parameters, gameplay cue parameters and cue parameters, const gameplay effect spec for RPC and spec, virtual void init gameplay cue parameters _g spec, gameplay cue parameters and cue parameters, const gameplay effect spec and spec, virtual void init gameplay cue parameters, gameplay cue parameters and cue parameters, const gameplay effect context handle and effect context. Up arrow back to top 4.8.5 gameplay cue manager. By default, the gameplay cue manager will scan the entire game directory for gameplay cue notifies and load them into memory on play. We can change the path where the gameplay cue manager scans by setting it in the default game.ini. /script /gameplay abilities.ability system globals, gameplay cue notify paths equals /game/gas documentation /characters. We do want the gameplay cue manager to scan and find all of the gameplay cue notifies, however, we don't want it to async load every single one on play. This will put every gameplay cue notify and all of their referenced sounds and particles into memory regardless if they're even used in a level. In a large game like Paragon, this can be hundreds of megabytes of unneeded assets in memory and cause hitching and game freezes on startup. An alternative to async loading every gameplay cue on startup is to only async load gameplay cues as they're triggered in-game. This mitigates the unnecessary memory usage and potential game hard freezes while async loading every gameplay cue in exchange for potentially delayed effects for the first time that a specific gameplay cue is triggered during play. This potential delay is non-existent for SSDs. I have not tested on a HDD. If using this option in the UE editor, there may be slight hitches or freezes during the first load of gameplay cues if the editor needs to compile particle systems. This is not an issue in builds as the particle systems will already be compiled. First we must subclass uGameplayQManager and tell the Ability System Globals class to use our uGameplayQManager subclass in default game.ini. /script /gameplay abilities.ability system globals, global gameplay queue manager class equals /script /paragon assets.pb gameplay queue manager. In our uGameplayQManager subclass, override should async load runtime object libraries. Virtual bool should async load runtime object libraries, const override, return false.